3.5D. So 3.5D has multiple parts. The first part is simplifying rational expressions. Then we're going to talk about multiplying and dividing rational expressions. Okay. On part A of this, our steps are as follows. We want to simplify. Some of the biggest mistakes that I see you guys do, you guys try to cancel out terms. You cannot cancel out terms. You only can cancel out factors. Okay. And so if there's an addition or subtraction symbol, you cannot just go through and say, there's an X, there's a 3, there's a 6, there's a 5. It does not work like that. Okay. You can only cancel out factors. Factors means that these things are being multiplied, right? That's what that means. Okay. So keep that in mind as we're doing this. First thing you want to do is factor everything. So using dots, using GCF, using simple trinomials, complex trinomials, you factor everything. Okay. Then you're going to rewrite as multiplication of the factors. You're going to simplify. When we say simplify, that means eliminate and combine. Eliminate and combine is what simplify means. Okay. Lastly, we're going to state the restriction on the variables. What can your variable not be? Okay. All right. So we're going to start off easy. If you look at example number one, these are all factors. This is factors. Why is it factors? Everything's being multiplied, right? There's nothing being added or subtracted. So this is just a group of factors, which tells me that I'm free to eliminate things. Does that make sense? Okay. So when we are eliminating, it's based on like terms. So if you have to visually, mentally separate, so you're only looking at negative 27 divided by 9 times x squared divided by x times y divided by y. That is what it's saying. Okay. So when you simplify, you're asking yourself, what is negative 27 divided by 9? Negative 3. What is x squared divided by x? X, because remember that you're subtracting the exponents. And 2 minus 1 is 1x left, right? And y divided by y is 1. 1. Y divided by y is 1 because you're subtracting, and anything to the 0 power is 1. Okay, is there any reason for me to write a 1? No, Casper can be invisible. So this is my simplified.
Wait, what happened? Right.
No.
So that. No, I thought we right. Oh.
Okay. Not bad when they're all factors, right? Because this is what I come down to. There are no restrictions on my x. X can be whatever it wants. Okay, there are no restrictions. Okay, typically we are fine when they're all factors. What happens is when they're not all factors, it's where we do weird things.
But what do you mean all factors? Like stuff that can divide it?
No, factors meaning that there's no addition or subtraction happening. It's just multiplication. Yes. So example 2 is where we kind of we're a little weird. Okay. I've seen people say, oh, there's a 6 here and a 6 there. They've crossed it out. Okay, that's not how it works. You cannot do that because these are being added and subtracted to other terms. So they can't just be crossed out because, oh, I have 2 negative 6s. Okay. No, you have to factor first and then eliminate. Okay. So first thing, this is a binomial. It is not difference of 2 squared. So the first thing you should always check for is GCF. Is there a GCF? What is it? 3. So I'm going to factor out 3 and I'm left with negative 2 plus x. Agreed? It's its own thing. Each one is its own. Okay. Our numerator's done. Our denominator is a simple trinomial. It's simple because your a value is a 1. So that means you're asking yourself what multiplies to give you 8, but adds to give you negative 6. What is it? What kind of form too? I need a negative 4 and a negative 2. Because negative 4 times negative 2 is 8. Negative 4 plus negative 2 is negative 6. Okay. Yes. All right. Now we are factors. So now that we are factors, we now can eliminate. Are there things I can eliminate?
-2, 4x to -2.
Exactly. Even though these are written in different ways, they are exactly the same, right? The negative, the 2's are negatives, the x are positives, so these can be eliminated. So now I'm left with 3 over x minus 4. And what can x not equal?
4.
4. Why can x not equal 4? Exactly. It would make it equal to 0. And can we have 0 in the denominator? No.
So the restriction is X.
The restriction is x doesn't equal 4.
The restrictions are only in the denominator.
The restrictions, yes, go back up. Our restrictions are where? Denominator. What would make the denominator equal to 0? Okay. Yes, and that is our answer. All right. Okay. 3, we're going to review how to interact with a complex trinomial. When you have a complex trinomial, we went over several ways of doing it. Based on people's results, I feel like for our class, the best way was Xbox. Where you are. Okay, the reason why it is a complex is because is my leading coefficient 1 anymore? No, it is something other than 1. When that happens, you have to multiply your leading coefficient times your constant. So you're doing 2 times -2 makes -4, and then you're looking at your middle term, which is -3.
Can we just do it the same way we worked in the first one?
This one?
No, the first one.
No, you can't. These are not, there's subtraction and addition happening.
There is subtraction and addition on the second one.
And we had to factor it. He said, can we do it like the first one? We
all do that.
No.
Hey, how did you get -4?
So to get -4, you have to multiply your A term times your C term. So 2 times -2 is -4. And our middle is -3. So you're asking yourself what multiplies to give you -4, but adds to give you -3. -4 and 1. That's because -4 plus 1 is -3. -4 times 1 is -4. So you either can go into grouping or you can go into the box, whichever way made it easier for you. I'm just trying to stick to 1. Okay, in the box, you are putting in your first term. So you have 2x squared, your last term, -2, and your numbers that made it work. Put them in inside, and then you fall in the outside. My first term, my last term, and the numbers that work. Now, all you're doing is GCF. What is the greatest common factor here? 1x. What is the greatest common factor here? -2. What is the greatest common factor here? 2x. What is the greatest common factor here? 1. So your factors for your numerator are 2x plus 1 over x minus 2. Okay, your factors for your denominator, it's simple. So you're just asking what multiplies to give you 6, but adds to give you -5. -2 and -3, good job. And what eliminates? X -2. So we're left with 2x plus 1 over x minus 3. What is your restriction? X cannot equal +3. Perfect. Okay. And we will pick up here mañana. All right, guys. So we're going to kind of quickly go through this, a recapping of what we did yesterday. So here we have rational expressions that we're simplifying, right? And we talked about in order to simplify, you want to factor your numerator and your denominator. Then you eliminate common factors. I'm sorry, not terms. Common factors, and then you state the restriction on the denominator, right? Okay, so that's what we're doing. So when we look at what we have here, our numerator, this is going to be an example of how would I factor this? Exactly. What multiplies, it's a simple. So what multiplies to give me -8, but adds to give me -2. We know it's a simple because your leading coefficient is cast with a friendly 1. Okay. So we need a -4 and a +2. Okay. How do we feel so far? Okay. The denominator is not simple. It is a complex. Okay. And when you have complex, that means you need your x. So the x, we gotta do the x. Okay. So we need the x. So we have 3 times -4 is -12. And what is our middle term? 4. So we're asking ourselves what multiplies to give us -12, but adds to give us 4. So what?
Wait, +6, negative.
We need a what? Say it again. +6 and -2. It's A times C. Okay. Huh? Yes, in your box. Yes. First box, first term, last box, last term. So in our first box is our first term, which is 3x squared. And the last box is our last term, which is -4. X marks the spot of what fills in. So we have 6x and -2x. Once I'm in the box, what am I doing? The GCF all the way around, right? So what is the GCF of the first row? 1x. What's the GCF of the second row? 2. What's the GCF of the first column? What's the GCF of the last column? -2. So my factors for my denominator are going to be x plus 2 and 3x minus 2. Do we see that? Okay. I'm going to say tutorials is needed. Yes.
Why did you put the -2x in the top right corner? Not that one.
It doesn't matter which one you, nope, does not matter. Wherever you put the x's, it does not matter. It's going to come out the same. Yep. Good question. All right. So after we have factored, now we do what? Eliminate. So what can be eliminated? X plus 2 and x plus 2, right? Because it's in the numerator and in the denominator. So we're left with 3x minus 2. Okay. What is our restriction? What can x not equal? Your restriction is based off of your denominator. What would make my denominator equal to 0 is what you're asking. I heard 2/3. Yes. Who said yes? So if I have 3x minus 2 equal to 0, I would add 2, right? And I'm left with 3x equals 2. Is x by itself? No. So I would have to add 3. So my restriction is 2/3. So that would be my final answer. Okay, x minus 4 over 3x minus 2, and the restriction is x cannot equal 2 over 3. All right, I'm going to pause. I'm going to be walking around. I want you to do number 5, okay? All right, so in your numerator, you should have used greatest common factor. In your denominator, you should have used complex, right? So GCF is 3, and we're left with x. I forgot my 2. My 2x plus 5. Yes. Okay. The denominator, we're going to use our complex. So 2 times -5 is -10. The bottom is the middle, and we get 3. So what multiplied to give you -10, but added to give you 3? There we go. We had a 5 and a -2. Okay. Remember your box Your box is your first term and last term. These are your terms. So we have 2x squared and we have -5. The other boxes come from your x's. So we have 5x and -2x. They came from my x, so they have an x. So the GCF here is 2x. The GCF here is 5. The GCF here is x. And the GCF here is -1. If your outer box is negative, then your GCF is going to be negative. Just like if it were parentheses, if your leading term is negative, your GCF is negative, right? So we're left with
-5, plus 5,
x minus 1. So what goes away? Our 2x plus 5. So our final is, and what's our restriction?
1.
Perfect. How we do?
That wouldn't.
Wasn't bad?
That cannot equal 1 to the asymptote.
It would be an asymptote, exactly. It would make it equal to 0. So. Mhm.
Yeah, this is one killing.
Okay, so in terms of what we've learned, this would be an asymptote, this would be a hole because I removed it, right? What's removable is a hole, what's not removable is your asymptote. Okay, good question and statement. All right, so I'm going to do the 2 variable with you just to show you that it's the same. So in this case, we have x and y. We can still apply our factoring strategies for x and y. These are both perfect squares that are being subtracted. So I can still apply difference of 2 squares, right? These are 2 terms that have things in common. So I can still apply GCF. Do we see that?
Yeah.
So the factors of my numerator are going to be x minus y times x plus y.
Wait, how did you know that top one not?
Because they're perfect squares that are being subtracted. My denominator, what's my GCF? 6x. And when I factor out 6x, I'm left with 1x and 1y. So now we can eliminate, and when we eliminate, our x plus y's go away, and we're left with over 6x. What can x not equal? 0. X can't equal 0 because 6 times 0 is 0. Okay. You're factoring.
But that's 0. 0 over 6 is 0.
Yeah. That's fine. Which last part?
We started about like how it can't equal 0.
Remember, you can't have 0 in the denominator. It is okay for 0 to be in the numerator because 0 divided by anything is 0. But it is no go for 0 to be in the denominator because there's nothing that you can that will produce this. So that's why this is 0, because 6x equals 0 means x has to be 0 in order for that to be true.
It's still a water.
Yeah. All right. Okay, so that concludes your part A, right? All right, part B is very similar to part A. The only difference here is that you are multiplying, which just means you have more things to factor. That's all it means, is that you have more things to factor, but you're still factoring and eliminating and reducing. That's it. That's all the difference is. Okay. So we're again just more factoring. And that's it. Okay. So let's dive on in. So let's look up here at number 1. See, what is it? More things to factor, right? I warned you that that's all it was. However, it's good to practice your factoring skills. So, how would I factor this one? Difference of 2 squares. Why is it difference of 2 squares? You have perfect squares that are being subtracted, right? Okay. How would I factor this one? Complex. Why? Because of this 2, right? There's 3 terms and the leading is not 1. Okay. How would I factor this one? Simple. Why is it simple? Because it's Casper the Friendly One in front. Okay. And these are the same. So once I find one, I know the other, right? All right. So let's begin to factor. So difference of two squares means I'm taking the square root of the first term and the square root of the second term. What is the square root of 4x squared? 2x. What is the square root of 1? 1. When you take the square root of something, you're going to have a positive and a negative. So we are done with that one. We're going to factor the second one, which is our denominator. So the second expression we have is 2x squared minus 5x minus 3. So it's complex, so that leads us to our x. So 2 times negative 3 is negative 6. Our b is negative 5. What multiplies to give me negative 6, but adds to give me negative 5? Negative 6 and 1. Agreed? Again, you could do grouping or the box, but I've noticed more people use the box than grouping. In the box, your first term goes in the first box, so we have 2x squared. Your last term goes in the last box. Your x marks the spot of everything else. It doesn't matter where the 1 or the negative 6 go. All we're doing is GCF all the way around. What is the GCF of the first row? All right, x, 1x, good job. What is the GCF of the second row? Negative 3. GCF of the third row? Column, that's not a row. 2x. GCF of the last column? 1. So these are my factors, right? So we have x minus 3, and we have 2x plus 1. These are going to be the same factors for the other denominator. Agreed? So x minus 3 and 2x plus 1.
Oh, wait.
Because they're the same.
Oh.
All right, simple is my favorite. What multiplies to give me 9, but adds to give me negative 6?
Negative 3. Oh, wait.
Negative 3, negative 3.
Negative 3 and negative 3. X. Negative 3 plus negative 3 is negative 6. A negative times a negative makes a positive. All right. What's left? We did it. Now we're on eliminating. All right. What can I eliminate? Perfect. Okay. What else? Perfect. You can cross because there was an x minus 3 here. You can cross the multiplication symbol. So what are we left with? That's what all of that simplified down to. Okay, what does x not equal? Good. What kind of? There we go. Negative 1/2.
That's pretty.
All of that came net. Okay, how do we feel? All right. We're going to pick up the pace. Y'all are going to tell me what to do. I'm not going to say anything. Complex. So for the first one, we're going to have to. Complex. Do I need to do anything to this one?
No.
Okay, for this one, expression 3.
Dots.
Dots. Perfect.
Oh.
This one?
Yeah.
Yes, perfect squares. And then 4. Simple. All right, let's go. So we're going to start with the expression number 1 in the numerator. Complex x. What goes in my x? Perfect. There we go. Good job. All right, what's next? Okay. Got it.
2x squared.
Cool.
That 3 at the bottom,
got it,
left,
okay,
the 6X.
all right.
Then GTO.
And now I'm gonna GCF. So what is my GCF?
First row is
X,
Cool,
the other one is 3.
perfect,
That's 2X.
2X.
good, great. Oh my gosh, they were so similar. Good job. Exactly. You know, similar. All right, expression 2. Is it good to go?
Yeah.
Okay. On to expression 3. What happens? Exactly. Say it. And why am I doing that? Dots, difference of 2 squares. That's a perfect square and that's a perfect square. Done. Perfect. Look at y'all. All right. Done. What's left? All right, who gets to go away? Okay, okay. Hold on. This one and that one. Anything else? There we go. So our final answer is
2X plus 1. Over X plus 5.
and what is your restriction?
X.
X.
Negative 5.
-5. Conclusion of multiplication, huh? It is, right? A little bit.
It's like really easy. It's just like, it's just, you gotta know what to do. Yeah.
Good. All right. A lot of times you guys forget algebra 1 after we do a little bit of algebra 2. So number 3 is an algebra 1 refresh. Okay. So looking at this, going back into that algebra 1 file cabinet, you can. So there's a couple ways of solving it. You can just multiply and then reduce, or you can reduce then multiply. I want you to do whichever one you want, refreshing your algebra 1 skills.
Wait, Lydia.
What do we do? Butterfly?
Would we do 5
What do we
times
do?
12 or would we do 5? Yeah, 5 times 12 YX.
Yeah.
60 YX.
So take a couple minutes, dust off that algebra 1 brain. And either you multiply, then reduce, or you reduce, then multiply. Does it matter which way you go?
Absolutely.
Absolutely not.
Wait, Lydia? Yeah. And what's the part across the top? Can we do 4 times 7 because it's X squared? You can still, you multiply the things that are the same. Since they're both numbers.
I don't want y'all to forget algebra 1, which tends to happen. Why are you looking at that? Let me check. There gets more. You can reduce your variable and your number. Yeah, you can reduce by 2 again.
No, you don't.
Whatever eliminates, yeah.
Oh, yeah. So if you reduce it by.
Yes, can you reduce any more? Or are you done? No. Remember that. All right, let's see what we did. By raising your hands, how many people multiplied then reduced? So I can know which way to go. Okay. So we multiplied then reduced. Cool, cool, cool. I'm a reduce then multiply kind of girl. Yeah. I like to work with smaller number as possible.
Wait, but how would you reduce? it?
Before, oh, I will gladly show you. I would go ahead and get rid of the 4 and turn 12 into a 3. I would go ahead and get rid of an X, and I would go ahead and get rid of my Y's
Wait, why? Okay.
because there's 2 of them and I only had 1.
That's a little, that doesn't.
And I'm left with 7X over 15.
I'm trying to combine things that didn't go together, and then I just confused.
That's why I said you could do either way, right?
You can do it either way.
How do I get rid of the 2? Because this means I have 2 X's up here and I only have 1 that I can eliminate. So it goes from being 2 to only being 1X.
You know, she did it better.
Yeah.
Yeah, just do that, like.
Sure, we just all, you know, I didn't get
Yeah, it's just saying that it's squared. So this is 4, and it means you have 2 X's here. X squared means I have 2 X's. And this is 5Y, and this is 7Y over 12X. So I'm taking away one of those X's because and I can take away 4 because it makes my 12A 3. But we will do it your way. Here we go. Multiplying, multiplication, numerator times numerator, denominator times denominator. Please do not cross multiply. You only cross multiply if there is an equal sign in between, not when there is a product. Okay?
I don't understand how the 4 makes it another 12.
Because you divide, they reduce, equals 4 divided by 12 is 1/3. I have a 1 in the numerator and a 3 in the denominator. Yeah. But multiplying 4 times 7, 28. X squared over Y. 5 times 12 is 60. XY. Okay, 28 and 60, their greatest common factor would be 4. I can divide both of these by 4. I divide U by 4. I divide U by 4. My X is still eliminating, and so is my Y. So I'm left with 7X over 15, either way.
Would it be 7 over 15 X or 7?
Your X is in the numerator. That's where the most of the X's existed. Okay, if you think about it in terms of subtracting powers, it'll be 2 minus 1, and that X is still in the numerator. Okay, all right, so that's our little algebra 2 little recap. It is what? Just wait. All right, when you're dividing rational expressions, the only difference from multiplication is that there's a division symbol, right? However, when we learn how to divide fractions, if I had A divided by A over B divided by C over D, how were you taught to solve this? You do what? You flip it. You reciprocal. You multiply by the reciprocal. If your teacher was really cool, they would have said keep, change, flip. Right? You're going to keep the first fraction, change from division to multiplication, and flip the second fraction. After that, it just is multiplication. And the same thing that we did in part B is the same thing that's going to happen in part C. Okay? So these 2 steps right here are interchangeable. Whether you factor first or reciprocate first is 100% up to you, or you do it at the same time. Okay? But after that, all the steps are the same. It's just this right here. Okay? So again, when we are dividing fractions, we're multiplying by the reciprocal, right? So we have to keep, change, and flip. All right? That's all we're doing. So we're going to dive in and see what happens. All right?
Wait.
What are you writing? All right, so looking at the first one, here we have 16x squared divided by 3y squared divided by 8x divided by 9y, right? So we're going to follow keep, change, flip. So we have 16x squared divided by 3y squared. Instead of division, it becomes times 9y over 8x. We keep, change, flip.
And then we do the same thing.
And then we just did the same thing that you should have learned in Algebra 1. Again, I'm a reducer before. So I reduced before. 16 and 8 become 2 and 1. Do we see that? 3 and 9 become 3 and 1. Yes? I have y squared and y. So I can take away a y to eliminate a y. I have x squared and x. I can take away an x to eliminate an x. And what am I left with? 2x and 3 makes what? 6x over y. That's not a y. That's not a y. And what can y not equal? 0.
And where do we put like multiplication division columns that turn into like a graph?
That numbers, there's multiple representations of numbers. All right, so here again, we are keeping, changing, and flipping. Okay, so I'm going to factor and leave the factors as they are. I'm going to change from division to multiplication, and I'm going to factor, but I'm going to flip the factors, right? All right, so the first one is simple, right? And what am I asking myself?
What adds?
Exactly. What's going to multiply to give me negative 15, but adds to give me 2? What are my numbers? What kind of 5 and 3?
5 and negative, no, negative 5 and 3.
Switch it.
5 and negative.
There you go. So I need a positive 5 and a negative 3. Okay, my denominator, how do I simplify that? I mean, factor that. Dots. Difference of 2 squares, right? Perfect. Good job, guys. All right, I'm multiplying. I got to remember that when I factor, I'm going to put it in its opposite place, right? X plus 1. Do I need to do anything to it? Nope. So it's going to go straight into the denominator. And then 3x minus 12, how do I factor that? GCF, greatest common factor. And what is the greatest common factor? 3. Perfect. And that leaves me with? And then is this any different than multiplication? Nope. So now we're eliminating. Huh? I can eliminate x minus 4 only, right? I don't see anything else that can be eliminated. So we're left with 3x plus 5 times x minus 3 all over x plus 4 times x plus 1. What are my restrictions? X can't equal what?
5, negative 5.
There we go. Negative 4 or negative 1, right?
Why is it all?
Because there's 2 factors left. So there's 2 things that can make this equal to 0. All right. On you. You got it. You got this. Yeah, you do. They're all GCF. They're all GCF, guys. They're all GCF. Okay. We can be delusional.
That's pretty.
Anthony, you left your ID here yesterday.
I know, man. I figured it was well, thanks, man. Always like, if anyone were to find it, they'd be doing right to it.
Yeah.
Thank you.
Welcome.
I don't have to pay for it, do I?
Yeah. They gave that up a long time ago.
I can't let it help them work, like trying to charge high school students for an ID everything.
I did, my high school did $5 if you lost right there. And you needed a senior and you can get off campus.
Brooke,
But like for temporary, but they're trying to charge people for a sticker, I think that one.
Oh, no, you had to have a hard ID to get off campus at my school.
Yeah, but like, Last year they were trying to target people for a temporary, and I was like, no.
Well, the plan is, if they were consistent with it, you would get tired of paying $1.
Yeah,
There's people I've been giving, like, I'm on Thursdays, I do duty, there's people I've been giving temporaries to since September. So.
The girl is gonna realize.
Exactly.
Well,
Can't
You
realize
can
it.
get two pieces in your back.
isn't really open to get like, you can't really get that if you don't have that.
You're supposed to go during your lunch.
Is the office ever open?
Yeah, but this one.
They've been closed always, I think.
No, they're open. Are we ready to check?
Hold up, no, I got distracted.
Oh, my bad. I'll take blame.
Can you cancel out across the top?
No, bottom and top only.
Okay.
She said across the top. That's multiplication.
Oh, I remember it.
You multiply something wrong. Yeah. I was like, you multiplied something wrong. Yes. I was like, oh, America.
Am I going crazy?
Nope. What'd y'all get? Yay.
I was like.
All right, so GCFing it really quick. We have 3 y minus 4 over 2 y plus 2. Yes. All right, keep change, flip. So these are, remember, are switching their locations. So GCF here is 6 y minus 4. GCF here is 4 y plus 2. And what happens? Oh my gosh, all of these factors do what? They cancel out, 3 times 4 is 12. 2 times 6 is, what does that equal? 1. All of that became a 1. All right.
Why does it just write 1?
You don't know where the numbers came from or the data, so there's different reasons. All right, so that concludes our 3.5D.